So hi guys, this is the second video of single wire antenna, and we're going to talk about how single wire antenna works and how energy is radiated. So let's talk about this. Imagine a wire is placed on the z-axis, and let's take a QL, which is charge per unit length, and Ij is the current flowing in the wire. Vz is equals to the velocity of the charge in z-axis. Az is equals to acceleration in z-axis. I've just kept this for the future reference, and this is the length of the wire. So as simple as it is, first write this. How this came, you'll understand. Charge into velocity is equals to current, because charge is charge, and velocity is, there is charge per unit length, right? And I've just written it here, charge per unit length, and velocity is equals to length per time. And when you cut this, q upon t is equals to I, simple, just for understanding. And you can differentiate it with both side with respect to t, and when you do that, you'll get diz upon dt. Ql is equals to constant, and vz is not constant because the velocity is changing and into an acceleration. The charge is accelerated. So you can just see, and when we do the derivation, we can actually get this equation. So yeah, two factors are very important. Let's read this first. To create radiation, there must be time varying current and acceleration. There must be time varying current. There must be time varying current, which equals to this, and there must be acceleration, which equals to this. That creates radiation. Acceleration, it doesn't mean that you have to have acceleration in the positive direction. It can be either like deceleration as well. So this is the fundamental relation of electromagnetic radiation in single wire antenna. So okay, but since we've just concluded it, we cannot just say everything conducts wire. There are certain conditions. If the charge is not moving at all, the current is not created, and then there is no radiation. This is simple. But if charge is moving with uniform velocity, in straight wire there is no radiation in the case of uniform velocity. Okay, because acceleration means also changing the direction, Nita. And in the straight wire there is no acceleration because we have just considered uniform velocity. But in the curved or bent or zigzag wire radiation, the wire is bent. That means that even if the acceleration is not in the not changing its value, its magnitude, we can still conclude that acceleration is constantly changing because of its direction. So if the wire is straight and the charges are oscillating in the time motion, also radiation happens. But if charges are also oscillating, we can have in time motion radiation happens. So three conditions: if charge is not moving, current is not created, so no radiation. If charge is moving but in straight line, there is no radiation. But in the curved or bend condition, due to acceleration's direction being changed, we can actually find radiation. But even if the wire is straight and the charges are oscillating in time motion, charges are oscillating in time motion, there is also radiation happening there. So this is the single wire antenna.